Alright guys, so let's imagine that I hook this metal ring up to a battery here. Alright? And so when I hook it up to this battery, electric charge will run from the battery, it'll run through the wire, like so, and it'll keep going around until it hits the loop. When it hits the loop, it'll then go around the loop, alright? So there it is going around the loop. And then it keeps going and comes back to the other side and returns back to the battery. Alright? So this is one way to charge a metal loop, but that's not the only way to produce an electric charge. You can actually charge a metal loop without using a battery. Okay? And you do that via a magnetic field. So a magnetic field can actually produce electricity. Alright? So if you take this ring and if you move it through the magnetic field, it'll actually produce electricity. But you have to do it in a specific way. You have to move this ring in an up and down way like this. So if I have the ring down here, the only way that I can produce electricity in this ring is by moving it perpendicularly to the magnetic field. So the ring is moving up and the magnetic field is running horizontally. So the ring's running perfectly vertically while the magnetic field is horizontal. And so I run it through, and what this does is it actually makes charges push through the ring, all right? And that push of charges causes the electricity, all right? Now, there's my cat, but this won't work. This actually won't produce electricity if I take this ring and I run it horizontally, all right? Another word for this is parallel. I'm running this ring parallel to the magnetic field. I actually won't be able to produce an electric current in the ring this way, only if I run it this way. If I run it perpendicularly to the magnetic field, I can cause charges to move in the ring, but if I run it parallel to the magnetic field, nothing happens. Okay, this ring is not charged when I move it this way. And if you were to look at this a little closer, you'd see something like this. So here's an example of a wire, and this wire is, you can see these yellow arrows here. This wire is moving down, all right? And the magnetic field shown in blue here, in the blue arrows, is moving horizontally. Let's act like it's completely flat here, all right? Well, since the motion of the wire is perpendicular to the magnetic field, it is causing these charges to flow through the wire. All right, these charges are now flowing through the wire because of the perpendicular relationship between the wire's motion and the magnetic field. All right. As you can see here, these charges will not flow through the wire if the wire's motion is parallel to the magnetic field. All right, we have the motion of the wire shown in yellow there, so act like the wire is moving that way. And it's moving in the exact same direction as the magnetic field. And these lines are parallel, all right? So if the movement is perpendicular, you will have electricity. So when you're thinking perpendicular, think of a lowercase t or even an uppercase t. So when a metal loop is moving perpendicular to a magnetic field, you'll have electricity. But when it's moving parallel to a magnetic field, there will be no electricity.